Hello, good afternoon, good morning, good evening, whichever it happens to be, wherever you are. Because somewhere right now it's morning, and somewhere it's afternoon, and somewhere it's evening or night. So all of it is appropriate. What we have on the bench today, my messy and very hot workbench. It's about 100, I'm guessing, but it was 104 yesterday, probably 100 today. So if I get a little bit delirious, you'll have to forgive me. But we have a 1492 on the board, on the bench. See, I already messed up. And this board was sent in along with another board that was purchased to use as parts. And both of the boards actually suffered a little bit of damage in shipping. Well, just first let me give some background. I've been working with the customer to give him some advice as to what components he might want to check to see if we could get it going on his end. But you can only do so much of that before you need to start probing around on the board and testing components that you know are suspicious and getting a feel for how the capacitors are, the diodes, other components, what you're getting for readings when you test across components. But the very first thing that I noticed when I pulled the first board out, well, they were shipped kind of like this, one on top of the other like this. And you can see, maybe you can't see, the flyback, look back here, is not all the way down. I can stick the little finger of my pointer. Maybe this one would be better. I can get the whole thing underneath it. That should be pressed all the way down on the board. And then the flyback gets soldered in. Well, what happened was in shipping, this got pressed either by the other board or dropped in shipping, when they handle boxes. And it shoved the traces off the board. That trace is literally popped off the board. This one's busted. I haven't tested it for continuity. That one's broken for sure. That's a two-piece trace, but it really needs both of them, so I'll need to fix that. I am going to, when I'm done doing my summary, I'm going to start up the desolder gun, and I'm going to undo all of these, and then I'm going to press it back on. He's already replaced the vertical IC and a couple of capacitors. But a few things that I wanted to go over right away that I see as problems why this board would not start at all. Well, it won't start at all, or why it wouldn't have a picture if it does start. I've identified a few things. Let me get my meter, pumpkin eater. Hopefully you can see the meter and the board. I already did a little probing around. The vertical IC does not test shorted. It tests not shorted. That doesn't mean it's good, as I have said in other videos. It just means that it's not shorted, which is one of the ways it can die. But when I was looking on the top side of the board, I noticed this resistor, number 303, so it's gray, black, it's toasted. It measures open, and I'll show you in a minute, And this one, number 307, can you see in there? I'm going to poke in there. There it is. Number 307 is toasted. Now, I don't know why it's toasted. That's the curious part. But he's already swapped the flyback off of the donor board onto here. So it's possible that the flyback went out with grandeur. There's also, okay, so there's those two resistors that are fried. These diodes back in here all test good. And the Zener diode, which is the most important diode in the power circuit. Try to get some better light here. It's fine. And the diode here by the XRC5184, it tests good. Okay. The IRF 831 does not test shorted, and neither does the C2344 here in the vertical section. Nothing obvious on the back of the board. There's a few pins here that do need to be reflowed, just because the solder is getting a little dry, but nothing obvious there. But if this board starts and it doesn't have a picture, well, this is a capacitance meter. It is approved for testing capacitance in circuit. The customer already replaced 286 in the power section and 230 and 233, because the board will not start without, if these are bad enough up here, even though these are not technically in the power circuit, you won't get a picture if these are bad. But those aren't the only ones that can cause problems. Trying to get that so there's no glare. Look at the reading 125, 126, and 127. There's one for red, green, and blue, or it's red, blue, and green, whatever it is. The resistance on those, the ESR is 0.7K, and it measures 122 nanofarad. No, 1,244 nano. Well, those are supposed to be 10 microfarad capacitors. So you could have no color or the color, and they're all the same, equally bad. 0.7K, 0.66K. You could end up with squirrely colors or colors that just look bad or just any kind of weird things going on in color. And 201, yeah, tests 415 nano and 3K ohms of ESR, over 3K ohms of ESR. That could cause the vertical circuit to go into fast chirp and not want to boot. So that's got to be replaced before I don't even want to try to power this board up. It's pointless, especially with that broken. So if I'm going to turn on my desolder gun and start fixing this, I'm going to replace those. I haven't tested these 225. (108 microfarad). Well, that's okay. It's weird that it would measure over 100. 108. Okay, well, they're probably okay. And then down here, that's fine. 94 microfarad. This board has been exposed to something. This weird, so I don't know if you can see it in the video. You can see how the traces that are normally green coated and look, so the board is technically kind of a yellow color, but the coating on it turns it green. Well, the copper traces are covered with green and it makes them look bronze. When it gets exposed to, when either a capacitor gases out, when that happens, a lot of people think that, well, you look at the bottom of the capacitor and it's going to damage the top of the board. Well, depending upon where the board is, what game it's in, and what the air circulation is doing, when a capacitor gases out and leaks, it actually condenses inside of the cabinet of the machine. And that gas, or if there was a liquid of any kind, gets on this coating and starts making it look like it has black freckles. And the first thing I noticed here is that this solder joint looks chalky, and you can hear it. I mean, a normal solder joint is smooth, but this is like a chalkboard. And once these traces burn through all the way, once this protective coating burns through to the traces all the way, or is on there long enough, it actually converts the copper into non-metal. It turns it into, I don't know, you would have to look it up and read about it. You can just ask Google, tell me what happens when copper traces are exposed to, acid, and it'll tell you it converts it away from metal. You can't solder onto it anymore because it's not really metal anymore. So this needs to be cleaned and neutralized before it goes through. I will do that. And these solder joints need to be reflowed at the very least. I'll brush them off and see if I can return the surface to a usable surface and reflow those. But that's not good. I don't think I ever tested that capacitor. 286 nano, 5K ohms. So you would have all kinds of weird video images on this. You could have retrace lines, not likely, but you could have weird issues with your, the retrace lines might restart too soon, and you might end up with weird things with the sizing, or the left and right side could do weird shapes or things like that with these capacitors that far out. That one anyways. So that one needs to be done too. Okay. And I didn't test the vertical capacitor. That capacitor could just be completely dead. see the meter? Well, if that capacitor really is dead, it wouldn't start. Let's see if I can get it in here. Oh, 447. Maybe it just had some oxidization on the leads. There we go. It's good. Probably just had some oxidization on it. Maybe those solder joints got hit with whatever happened to the rest of the board down here. Okay. I'm going to start up the desolder gun. And let's see. Alcohol doesn't really neutralize acid. But if it's on there, it can wash it away. Oh, good. A lot of that washed off. There's still... But... Okay. I think I can work with those solder joints. I'll just take the solder out. Okay, I'm going to warm up the desolder gun and get ready to remove the flyback and replace the rest of these capacitors. And then we'll get to work on it. Is that a crack on the board? That would be a critical. I think it's just a scratch. Okay. Okay. Just a scratch on the surface. Okie doke. Be back in a minute. It'll be a brief instantaneous blip for you, but when I come back, I'll have the gun ready and I'll have gone to get something to drink and hydrate myself before I dive in on this. And poof, I'm back. It's a 103.8 outside. if anybody cares. And it is 98 or 99 in here, depending upon where I take it in here. It's not bad. For those of you that live in the humidity belt of the world, or of the States, I've been there. I know what it's like. I've been in Virginia. And it is so humid that you had to leave your windows down a crack, otherwise your car would steam up. I don't know how you do it. I was recently in England and France when they had their heat wave. And it was just as draining when it was 95 to 100 degrees there as it is when it's, well, it was more. It was more draining there when it was 95 than it is when it's 101 or 2 here in California. I'm in almost desert region, somewhere between Los Angeles and Palm Springs, kind of in the middle, and it's very dry. So if we do get humidity, or the once a year, somewhere around Labor Day, we'll usually get a little spitting of rain. And it's nasty. And the reason I'm talking right now, nobody wants to hear that, I'm sure, is because I'm organizing my solder gun, or iron. Got a mess going on there with my cables I'm gonna have to reorganize. But for now I'm gonna add some solder to a couple of these joints so that the solder doesn't mess up my station. I'm actually gonna add a little solder to the vertical IC and redo these. I need to look at those joints. I could probably get those off, no problem. But these capacitors down here, yeah, see, that solder doesn't even want to take new solder. Get rid of that. That solder started to convert into whatever solder starts to convert into. It's like working with glue. It sticks to the iron. What else was I gonna do? Oh, yeah. And all of these are gonna get done. Okay. All right, well, we'll see how it goes. My solder gun is all plugged. There we go. Get rid of the charge cable. typically take more than one out at a time. But these three are all the same value, and that one, I won't pull it until I'm ready to replace it. Okay. Got the new ones. I just got a new batch in. I just want to spot check them. These are great. So these are what 10s should look like. Perfect, okay. We tested this one in circuit. Just to verify, we'll test it out of circuit. Well, that one's not bad. 93, 142. Still needs to be replaced, but 125. Yeah, nothing wrong with that one, but they have to be replaced anyhow. After 20 years or so, this seal on the bottom, well, in the 1980s, when was this made? 1993, so there was this era, all the 80s through early 90s, where these capacitors were over-engineered, and you can... I have some Ceronix 1490s that had original capacitors on them. This one's been replaced. Well, there's an original blue one. I just haven't got around to replacing it yet. But there are some capacitors that are original from these, and these are like 1988. They test perfectly fine. Then there was this era in the early 2000s where there was, I think they called it the electrolyte scandal or something like that. It was some weird thing. You can look it up. You can say I'm full of BS or whatever, but you can look it up, where the electrolyte that was being sold was defective, and all of these manufacturers that manufactured capacitors, oh, the garbage man's here, that's what the noise is, that manufactured capacitors for high-tech equipment got bad batches of electrolyte or electrolytic paste or whatever they call it. And there were capacitors that were blowing themselves up within a year or two. And it affected all of this high-tech stereo equipment. It was like until 2007, or 2002 until 2007. Anyway, that plastic seal in the 70s and 80s through early 90s was really, really good, over-engineered. The electrolyte was really well sealed. Paired with the fact that Ceronix engineered these boards really well, where they placed the electrolytic capacitors as far away from heat-producing components as possible. Most of them are sitting out here in the open. There is one right next to well, there's two, but even that one's pretty well spaced away from the vertical IC, but they're all engineered so that they're far away from the heat-producing components, which allowed them to go 10, 15, 20, 30 years without needing to have the capacitors replaced. So there's your history lesson on electrolyte or electrolytic paste, or whatever they call it, that's inside of electrolytic capacitors. I can't remember. Oh, I do remember now. Whew. 380 nanofarad and 3K ohms. That's basically a resistor in circuit. Okay, all three of these need to be done. And I also just noticed these leads down here. I know I snipped off the other ones that were over here, but those are almost touching each other. Okay, I'm gonna pause. I'm going to replace these three, and I will be back. Okay, Puff, I'm back. There's one other capacitor that needs to be tested. And when you order capacitor kits for Ceronix 1492, they do not come with this capacitor unless you buy them from me. And I contain it. My kit contains it. This surface mount capacitor on PRAH, not all boards have it. Some boards have a PRAH board that doesn't have a capacitor on it. But that one right there, it's a 10 microfarad, 16 volt, and it can really mess with your image if it's bad. Probably won't stop it from booting, but it can really mess with your image. Oh, wow. $1608 pico. So what's that, like 1 microfarad and 11k ohms. That capacitor is shot. So when you replace that capacitor, you want to be careful because these PRA boards, you can't solder to the traces on them. And that PRA board has the same problem as the bottom of the board. Yeah, one of these capacitors or something gassed out. I might have to wash this board. Okay. So you don't want to yank too hard on it and break the surface of the trace. I am going to add some solder to it if it will let me add solder. If not, I might have to snip those leads. Yeah, they're just smoking. Okay, let's hope we can do this. It's like playing that game Operation. And by doing that, we gave ourselves wire to be able to attach to on the board. I'll add a little bit of flux to it. Be right back. Alright, I have my fiberglass cleaning pencil. It's down to the last nib. I have a replacement, but I want to use every last bit. The leads from the capacitor are equally messed up. Can't get solder to stick to it. I think I got it tinned enough. Okay. And the negative lead goes towards the flyback. Not pretty, but works. Okay. Oh, wow. Yeah. Well. Deal with that in a minute. I'll pause while I go through this painful process. Okay, flyback is out. I don't see any major cracks on it that would lead to arcing. That's good. Now, normally when a trace breaks like this on a component, I wouldn't worry about it too much. I would just bend the leg of the component and just make contact, clean it, use that fiberglass pencil cleaner, bend the leg over and attach to it. These are pretty significant traces, so what I'm gonna do here on this, so I just put some super glue on a piece of paper and I'm going to lift the trace put the trace down. Center it up. Okay. All right. Okay, those look good. That one needs to go back down. You want to be careful doing this because if you get super glue on the top of the trace, solder won't stick to it. Then you have to scrape the super glue off. And that's not fun. And always center up the hole so that when you put the fly back in, it doesn't push it through. Do the same thing again. That one got hit really hard. Gotta flatten that back out. Oops. Now this one, gotta take it down to copper. Okay. Oh, I just set down the piece of trace. I think it's sitting on the board and I can't see it. right back. Okay, yes, it was sitting on the board and I couldn't see it. So I can now look at this one and see if that trace is good. This one I believe broke, so I need to brush that. Bridge the solder. Every one of these will need to be continuity tested after the flyback is installed, because I have to bridge the solder here too. Okay, I believe those look good. So I will go ahead and put the flyback in. That one lifted a little bit. Well, I'll fix that after. Oh, and this needs... Yeah, looks good. Nicotine stains from its days in the casino. Okay. Looks good. Now the one thing I haven't done yet, I haven't tested these 1000 microfarad capacitors yet. They're rarely out of spec. But they do need to be tested, because sometimes, especially since we still have 2 resistors to deal with that have blown up, screw the flyback in first. Especially important on a board where the traces have been damaged, because the traces are ultimately then at that point holding the flyback in. And in some boards, if the traces are really good, you don't have to worry about it. But in this board, we need to worry about it. The flyback needs it absolutely needs the mechanical strength of the screws. Here into one of these. The fresh scent of cyanoacrylate adhesive boiling under the heat of a solder iron. That one needs to be jumped. There we go. And we know this one will need to be jumped. There we go. All right. The other filament. Oh no, sorry, that one's the other filament. Okay. Okay. I got those cleared. This one had a trace repair already. Okay. Now number 2 has to go up and down. Number 4 goes up. That one has the repair. This one goes over here. That one goes there. Okay. think we're ready to test it. Other than those capacitors. The 1000s. Good. These are the filter capacitors on the power supply. They measure somewhere around 135. They're 150 microfarad. They measure somewhere between 135 and 145. One of the common problems on these is sometimes the capacitor will pop out of the solder joint. It's, you know, if they've been shipped and jarred, they can pop right out of the solder joint. You wouldn't even notice. And then somebody complains that the board won't start. Well, the power supply can't start because capacitors aren't in circuit. Look at that bent tabby doodle on the board from shipping. Okay, I think I'm ready to live test, even though I don't know what this board is jumped for. I don't know what brand of machine it's jumped for. It should at least light up on my tube, I would think, or the colors might be inverted, or super bright. Oh, the two resistors. Ah. We still don't know why they fried. .303 is a 270. To what? To what? Okay. Well, I don't want to double up resistors, so we'll get a donor board and we will pull enough of a donor board. But before I put this into the bag, I did want to show completely open. Okay, got a nice looking donor off of one of my boards. Didn't want to pull off of the donor board he sent in case that board has hope. There we go. Those both need to be cleaned up. Look at that one, nice and toasty. I think that one's completely open also. Oh, 99 ohms. $470 ohm, half a watt. Okay, I pulled one because I remembered these were half watt, and I didn't want to take the time to look up if it's a protective diode. If it's a protective diode, then its rating is important, its wattage rating. I don't think it is. I think it's just a jumper across the Z jumper. Instead of Z jumper being jumped dead short, for some manufacturers, I don't know, Aristocrat or a couple of other manufacturers, you jump the Z jumper straight across, bypass the resistor. Okay, I think we're good to try it on a tube. Be right back. All right, so the board is now mounted inside the chassis. I have my video hooked up, my power, and connected to a variable AC power supply so I can raise the voltage slowly. and watch what's happening. And it is connected to a IGT PE game board. It may be messed up. If the image is messed up, I can, let's see, I can connect it to my test pattern generator. Oops, I bumped this and knocked my screws over. Okay, oh, sorry about the bouncing. Okay, power's on. I'm slowly raising the voltage. Okay, the board is chirping. Hang on, let me remove the camera from the tripod real quick. Okay. The power supply is at about 70 volts. So when you turn the power supply, I'm gonna turn it off. Okay, I'm on volts, so the volts go up. If I go to the current, as I start getting up close to 60 volts, between 60 and 80 volts, the power supply will start trying to come to life. And there it is. It's trying to draw current. Now I am also over here simultaneously. I'm clipped onto pin 8 of the LM324, and I'm going to be monitoring the voltage, the gain voltage. It's one of the secondary windings on the flyback that tells us how to set the gain. The goal is to get it set somewhere around 4.6 volts, I think. But so anyway, back to this. We're at about 80 volts, 70 to 80 volts. It's trying to start. It can't because it doesn't have enough power. But I'm going to go up and we're going to listen for it to chirp on. There it is. It's drawing about 0.5 amp. Very normal. And there's our image. Okay, the image is messed up because it's either inverted color or one of the colors is out. We know we have blue. See, those are normally yellow, I think. Black background is blue. There's a turquoise. Is that red? So, okay, we need my test pattern generator because I can invert the color on the test pattern generator. Whatever machine this board is from, the colors are inverted. So, hold tight. Okay, we're back with the tube on a test pattern generator. Let's see, I don't know if this is inverted. No. This is fine. A little bit out of focus. I'm going to move you here. Let's see. Somebody was moving the focus knob. Somebody. Okay. We got the flyback voltage up to about, I put it at 4.3 volts. It won't go any more to the left, so obviously whatever machine this goes on, the left-right adjustment is a little bit different. Colors look really good. Very nice, good linearity. Great colors. Voltage holding steady at 4.3. Okay, I think we call this a wrap. Yeah, everything looks really good on it. Wish I knew what kind of machine it was on. Ah, I do. Huh. Do I have a... Am I hitting something over here? Obviously we have something going on here, so I need to look at that. I don't know if it's because we're using a different board. Well, we have some touch sensitivity on the vertical AC. It's kind of hard to do adjustments like this when you don't know what the machine is that it's on. Okay, well, I think I'll go through, check out a few more things, look at some solder joints, look at that vertical IC, but for the just the general, for the overview and the mechanics of the board, it's working, and the board could be put in a machine after I touch up a few more solder joints and check a few things out. So that's good. At least we got one workable board. Pretty much an hour of work, and we got it running. Okie doke. Over and out. Well, what is this called? A post log? I don't remember what you call it. I know what prologue is, but... So the weird sync issue turned out to be I actually replaced two ICs. LM323, one of the little 8 legs that's in the sync circuit, coincidentally. And when I replaced it, the sync issue changed, But then the issue was it was way over to the left and it wrapped. And when I looked up the schematic, the next stop for the horizontal sink was LA 7851. The 20 pin. Interestingly enough, this is the second or third one that I've had to replace in the last month or so. I can go a year without replacing an LA 7851 or 7850, depending upon how old they are. The older ones had 7850s and the newer ones have the 7851s. And so I replaced it, and then boom, voila. We have our perfect alignment and no glitching, none of that weird stuff along the side. So my theory is that whatever took out those resistors stressed this one out, because that's what happened on the last board I worked on that needed this replaced. Was we had something else on the board that had fried. Oh, the vertical IC fried. Or we didn't know the order of appearance, but the vertical IC fried and it took this out, or this fried and it took the vertical IC out. But this worked for, I mean, if you lived through the length of this video, what is it, an hour and 10 minutes now? Hour and 5 minutes, something. You'll remember that it started looking decent, but then the edges started going. We basically got to see this fail. So it was already on the edge, and the leads right where they go into the IC are really dark. So I think it was operating really hot for a while, and I don't know, whatever happened to those resistors took those out. Now it looks really good. So that's it for this board. Really, 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 finally. So what did we have? Bunch of capacitors, bad. Oh, yes. I had an MPSA 64. I forgot that when I unsoldered MPSA 64, when I was checking it on the bottom of the board, I was getting a short between two legs. And then when I used the solder vacuum on the leads and pulled it off, one of the legs just fell off. So I think that one got toasted too. So I'm going to let it run for a while just to make sure that everything's good. Have the flyback dialed in, let it run for a few minutes, and call it done. I forgot about that other one, so yeah. Okay, there you have it. Good one.